heard the hype, the doubts, and the flat-out dismissals. But what if AI isn't just real, but already changing the world in ways you didn't even notice? Here are 10 undeniable reasons why AI is the real deal. Number 1. Proven practical applications. Artificial intelligence isn't just theoretical. It's actively saving lives in hospitals around the world. When a radiologist examines medical scans with AI assistance, they catch cancers at earlier, more treatable stages that might otherwise go undetected. This isn't futuristic speculation. It's happening today as AI systems analyze millions of medical images with accuracy that matches or exceeds human specialists. For patients receiving earlier diagnoses and more effective treatments, AI represents the difference between life and death. The modern financial system would collapse without AI's protective algorithms working tirelessly behind the scenes. Every time you make a purchase, artificial intelligence evaluates the transaction against your behavioral patterns, flagging potential fraud in milliseconds. These systems protect billions in assets daily, while enabling the seamless commerce we take for granted. When your elderly parent isn't drained of their retirement savings by sophisticated scammers, you're experiencing the very real benefits of AI security. Manufacturing facilities once plagued by costly, unexpected failures now operate with remarkable efficiency, thanks to AI-powered predictive maintenance. By analyzing subtle patterns in equipment performance data, these systems identify potential breakdowns before they occur, preventing production stoppages that once cost millions. This isn't marginal improvement, it's transformational technology reducing waste, conserving resources, and ensuring reliable production of everything from medical supplies to food products. Farmers facing increasingly unpredictable growing conditions now deploy AI systems that optimize irrigation, predict pest outbreaks, and maximize yields, while minimizing environmental impact. These practical applications help feed a growing global population while conserving precious water resources. For rural communities dependent on agricultural success, these tools represent economic survival in an era of climate uncertainty. The accessibility revolution powered by AI benefits millions with disabilities daily. Real-time speech-to-text transcription enables deaf and hard-of-hearing individuals to participate in conversations they once missed entirely. Computer vision systems describe surroundings for the visually impaired, granting new independence in navigation and daily tasks. These aren't just convenience features, they're life-changing technologies, breaking down barriers that have existed for centuries. Even creative fields, long considered uniquely human domains, now benefit from AI collaboration. Musicians, artists, and writers use AI tools to overcome creative blocks, explore new stylistic directions, and handle technical aspects of production. This augmentation of human creativity doesn't replace genuine artistic expression, but amplifies it, enabling creators to focus their energy on the most meaningful aspects of their work, while AI handles repetitive elements. The result isn't artificial creativity, but enhanced human expression, tangible proof that AI delivers practical value across virtually every field of human endeavor. Number 2. Robust mathematical foundations. Beneath the seemingly magical capabilities of artificial intelligence lies a bedrock of rigorous mathematics developed over decades by brilliant minds across multiple disciplines. AI isn't built on wishful thinking or marketing hype. It's constructed from foundational mathematical principles in linear algebra, calculus, probability theory, and statistics that have been tested, proven, and refined through countless peer-reviewed studies. When a neural network makes an accurate prediction, it does so through precise mathematical operations that transform input data according to optimized parameters discovered through systematic learning processes. The computational achievements powering today's AI systems would have been considered impossible just 15 years ago. A child who would have waited years for a proper diagnosis of a rare condition can now receive answers in minutes as AI analyzes their symptoms against vast medical knowledge bases. Behind this life-changing application are mathematical breakthroughs in optimization theory and computational efficiency that enable complex calculations to run on accessible hardware. These aren't academical curiosities, but practical advances that translate directly into faster, more reliable results for real people. AI skeptics often underestimate the sheer intellectual rigor that enables machines to perform tasks previously requiring human judgment. The mathematics of deep learning, particularly the backpropagation algorithms that allow systems to learn from their mistakes, represent one of humanity's most profound scientific achievements. These equations don't just describe reality. They enable machines to discover patterns and relationships too subtle for human perception, revealing insights in everything from climate science to materials engineering that would otherwise remain hidden from view. The ability of modern AI to generalize from specific examples to novel situations emerges directly from statistical learning theory, which provides mathematical guarantees about performance under certain conditions. This isn't random luck or empty marketing. It's applied mathematics working predictably to solve problems across domains. When an autonomous system safely navigates complex environments, or a language model generates coherent text on topics it wasn't explicitly trained on, these capabilities stem from mathematical principles that enable genuine learning rather than mere memorization. Perhaps most remarkably, the mathematical foundations of AI continue evolving rapidly, with researchers developing new theoretical frameworks that improve performance while requiring less data and computational resources. These advances aren't incremental tweaks, but fundamental breakthroughs that expand the range of solvable problems. Far from reaching theoretical limits, the mathematical underpinnings of artificial intelligence continue revealing new frontiers, with each advancement expanding what's possible, while making the technology more efficient, accessible, and powerful. This ongoing mathematical revolution ensures that AI's capabilities will continue growing in ways that deliver tangible benefits across every sector of society. Number 3. Demonstrated research milestones. The journey of artificial intelligence has been marked by concrete breakthroughs that skeptics once declared impossible. In 1997, when IBM's Deep Blue defeated world chess champion Garry Kasparov, critics dismissed it as mere brute force calculation rather than true intelligence. Yet this milestone represented the beginning of machines mastering complex strategic thinking. By 2016, when AlphaGo defeated Lee Sedol at Go, a game with possibilities vastly exceeding the atoms in the universe, even AI's harshest critics could no longer deny that something profound had occurred. These weren't marketing stunts, but documented research achievements published in prestigious scientific journals and validated by independent experts. Children diagnosed with rare genetic disorders often endured years of medical uncertainty and painful tests before receiving accurate diagnoses. Today, AI systems analyze facial features from ordinary photographs to identify genetic conditions with remarkable accuracy, sparing families the prolonged agony of uncertainty while enabling earlier interventions. This life-changing capability emerged directly from research milestones in computer vision and medical pattern recognition that transformed theoretical possibilities into practical diagnostic tools used by hospitals worldwide. The progression from narrow task-specific AI to today's multimodal systems that understand language, images, and context simultaneously represents one of humanity's most remarkable scientific achievements. Researchers who once struggled to build programs that could recognize basic objects have created systems that can interpret complex visual scenes, answer nuanced questions, and even generate creative content across multiple domains. Each step forward came through documented research breakthroughs, with capabilities expanding, not through marketing exaggeration, but through measurable progress verified through standardized benchmarks. When autonomous vehicles navigate complex urban environments, they draw upon decades of research milestones in sensor fusion, real-time decision-making, and predictive modeling. The systems preventing thousands of potential traffic accidents daily evolved through rigorous research that transformed theoretical possibilities into practical, life-saving technology. These aren't speculative future capabilities, but deployed systems, actively protecting passengers and pedestrians through intelligence derived from verified research discoveries. Perhaps most compelling is how AI research breakthroughs build upon each other, creating accelerated returns as each milestone enables new possibilities. The natural language processing capabilities that power today's conversation systems emerged from research advances in transformer architectures that revolutionized how machines understand context and meaning. This cascading effect of research milestones explains why AI capabilities continue expanding at rates that surprise even experts in the field. Far from empty promises, the trajectory of artificial intelligence follows a documented path of research achievements that consistently transform yesterday's impossibilities into today's practical applications, delivering tangible benefits that improve countless lives. Number 4. Performance gains over classical methods. The difference between classical computing approaches and modern AI is like comparing a horse-drawn carriage to a supersonic jet. In medical imaging, traditional computer vision algorithms once required experts to painstakingly program specific rules for detecting abnormalities, frequently missing subtle indicators of disease. Today's AI systems identify early-stage cancers with accuracy exceeding experienced radiologists, detecting patterns too faint for human perception. These aren't marginal improvements, but life-altering performance leaps that transform fatal diagnoses into treatable conditions caught months or years earlier than previously possible. Children struggling with learning disabilities once faced standardized educational approaches that left many behind. Classical educational software followed rigid, pre-programmed paths, regardless of a student's unique challenges. Modern AI tutoring systems adapt in real time to each child's specific learning patterns, identifying precisely where confusion occurs and adjusting explanations accordingly. For students who previously felt defeated by educational systems designed for neurotypical learners, these adaptive approaches create breakthrough moments of understanding that transform frustration into confidence and open doorways to futures once thought impossible. The manufacturing sector provides undeniable evidence of AI superiority over classical methods. Traditional predictive maintenance relied on fixed schedules or simple threshold alerts, leading to excessive downtime or catastrophic failures. AI systems analyzing vibration patterns, temperature fluctuations, and operational data now predict equipment failures weeks in advance with over 90% accuracy. This isn't incremental improvement, it's a fundamental shift that reduces costs by billions while ensuring critical infrastructure remains operational when needed most. Language translation once required rigid rules-based systems that produced awkward, often incomprehensible results. Today's neural machine translation delivers natural, contextually appropriate translations that preserve cultural nuances and specialized terminology. This quantum leap in performance connects people across language barriers, enables global commerce for small businesses, and provides access to vital information previously locked behind linguistic walls. For refugees seeking critical services in unfamiliar countries, or businesses expanding into international markets. The difference isn't academic, it's the distinction between confusion and clarity. Perhaps the most compelling evidence of AI's superior performance comes from fields where classical methods reached clear plateaus, despite decades of refinement. Drug discovery, materials science, and protein folding witnessed minimal progress for years using traditional computational approaches. AI methods have shattered these plateaus, accelerating discovery timelines from years to days, while identifying novel solutions human experts overlooked. The development of new antibiotics, advanced battery materials, and revolutionary medical treatments now proceeds at unprecedented speeds, addressing humanity's most pressing challenges with computational tools that genuinely qualify as breakthroughs, rather than incremental advances. These aren't hypothetical gains, but documented performance improvements, validated through rigorous scientific testing. Number 5. Ubiquity in everyday tools. The skepticism about AI's practical value evaporates when you realize it's already woven into the fabric of daily life, silently enhancing tools you use without a second thought. Every time your email client filters out spam, your streaming service recommends a movie, or your navigation app reroutes you around traffic, you're benefiting from artificial intelligence that works so seamlessly you barely notice its presence. This isn't futuristic technology, it's current reality, with AI functioning as an invisible assistant that saves you countless hours of frustration and wasted effort each day. The difference between contemporary smartphones and their predecessors from just 5 years ago lies primarily in the AI capabilities that enhance every aspect of their operation. When your camera automatically adjusts settings to capture perfect photos in challenging lighting conditions, recognizes faces to focus appropriately, or enhances image quality beyond the physical limitations of tiny phone lenses, it's employing sophisticated neural networks that transform mediocre snapshots into memories worth preserving. Parents capturing irreplaceable moments of their children's lives now preserve those memories with clarity that once required professional equipment and expertise. AI's integration into everyday productivity tools has fundamentally transformed how we work. Modern document editors suggest improvements to your writing. Presentation software automatically designs attractive slides from your content. And spreadsheet applications identify patterns in your data without requiring statistical expertise. These capabilities democratize professional quality output, allowing small businesses to compete with larger organizations and enabling individuals to produce work that previously required specialized skills. The single parent building a small business from home now creates marketing materials indistinguishable from those produced by dedicated professional teams. The voice assistants that have become household fixtures represent perhaps the most visible integration of AI into everyday tools. What began as novelty features that could answer basic questions have evolved into sophisticated systems that control smart homes, manage calendars, place orders, and serve as accessibility tools for those with physical limitations. For elderly individuals maintaining independence despite mobility challenges, these voice-controlled assistants provide crucial support that preserves dignity and autonomy. Number 6. Clear economic and business impact. The raw economic numbers alone demolish any argument that AI lacks substantive impact. Global productivity gains from AI implementation are projected to add $13 trillion to the world economy by 2030, representing the largest technological contribution to economic growth in human history. This isn't speculative forecasting, but a measurement of current trends, already transforming industries from manufacturing to healthcare. When a family business facing bankruptcy implements AI-driven inventory management and suddenly becomes profitable, the impact isn't theoretical. It represents jobs preserved, livelihoods protected, and communities stabilized through technological advancement that delivers measurable returns on investment. Healthcare provides perhaps the most compelling economic evidence of AI's transformative power. Hospitals implementing AI diagnostic tools report 30 to 40% reductions in unnecessary procedures, while improving patient outcomes through earlier, more accurate interventions. These systems don't just save money, they save lives while simultaneously reducing costs, addressing the seemingly impossible challenge of improving care quality while controlling expenses. For patients receiving life-saving treatments they couldn't otherwise afford because AI eliminated wasteful spending, these economic efficiencies translate directly into extended lifespans and improved quality of life. Small and medium businesses once struggled to compete with corporate giants that could afford massive data analysis operations. Today, AI-powered business intelligence tools level the playing field, enabling smaller organizations to extract actionable insights from their data without specialized expertise. Local retailers now predict inventory needs with accuracy, matching multinational chains. Service businesses optimize staffing to match demand patterns, and manufacturers identify efficiency opportunities previously visible only to companies with dedicated analytics departments. This democratization of analytical capabilities preserves economic diversity by enabling smaller enterprises to thrive in markets once dominated by corporations. The agricultural sector demonstrates AI's concrete economic benefits with remarkable clarity. Farms implementing AI-driven precision agriculture report average yield increases of 15 to 20%, while reducing water usage by 30% and pesticide application by 40%. These aren't marginal improvements, but transformational changes that simultaneously increase profitability and sustainability. For rural communities dependent on agricultural success, these economic gains represent the difference between exodus and revival, with technology enabling continued viability in an increasingly challenging climate environment. Perhaps most compelling is how AI addresses chronic labor shortages across critical sectors. In healthcare, transportation, manufacturing, and customer service, intelligent automation now handles routine tasks that organizations simply cannot staff at current wage rates. Rather than eliminating jobs, this automation increasingly preserves essential services by filling roles that would otherwise remain vacant. The hospital that maintains 24/7 patient monitoring despite nursing shortages, the logistics company that delivers critical supplies despite driver scarcity, and the manufacturer that keeps production lines running despite skilled labor gaps, all demonstrate AI's economic impact, not as theoretical potential, but as practical necessity. Without these systems, entire economic sectors would face collapse, making AI not merely beneficial, but increasingly essential to maintaining functional modern economies. Number 7. Growing body of peer-reviewed research. The scientific foundation of artificial intelligence stands validated by tens of thousands of peer-reviewed papers published in the world's most prestigious journals. Unlike corporate marketing claims or social media hype, these research findings undergo rigorous scrutiny by independent experts who verify methodologies, replicate results, and challenge conclusions before acceptance. From foundational mathematics to practical applications, AI research meets the same exacting standards applied across scientific disciplines, with breakthroughs documented in publications like Nature, Science, and specialized journals dedicated to machine learning. This enormous body of validated research represents not wishful thinking, but concrete evidence examined through the uncompromising lens of scientific methodology. Children diagnosed with rare diseases often faced years of suffering before receiving proper treatment, with families navigating endless medical appointments in search of answers. Recent peer-reviewed studies document how AI systems now identify patterns across thousands of symptoms, genetic markers, and patient histories, to diagnose conditions that previously confounded medical experts. The research published in the Journal of the American Medical Association demonstrates AI diagnosis rates exceeding 90% accuracy for conditions that typically required years to identify correctly. These aren't inflated corporate claims, but independently verified results that translate directly into reduced suffering for vulnerable patients. The environmental applications of AI have been exhaustively documented through peer-reviewed research, demonstrating capabilities that once seemed impossible. Conservation biologists now deploy systems that monitor endangered species populations by analyzing satellite imagery and acoustic data, with accuracy matching human experts but at vastly greater scale. Climate scientists leverage machine learning to predict extreme weather events with unprecedented precision, while environmental engineers optimize renewable energy systems through AI that maximizes efficiency. Each application builds upon published research, subjected to rigorous verification, creating a foundation of scientific evidence that withstands the most intense scrutiny. Perhaps most compelling is how quickly peer-reviewed AI research translates into practical applications compared to traditional scientific discoveries. The typical timeline from laboratory discovery to commercial application has collapsed from decades to months, with techniques published in academic journals rapidly incorporated into systems that solve real-world problems. The accelerated implementation cycle creates a virtuous feedback loop, where practical applications generate new data that informs further research, driving continued advancement through documented scientific progress, rather than incremental engineering improvements. The cross-disciplinary nature of AI research further strengthens its scientific credibility, with breakthroughs emerging from collaboration between experts in computer science, neuroscience, psychology, linguistics, mathematics, and dozens of application domains. This convergence of knowledge creates insights that no single field could generate independently, with each discipline bringing unique perspectives that strengthen the overall scientific foundation. Far from operating in isolated academic bubbles, AI researchers publish findings that undergo examination by diverse experts, ensuring that claims withstand investigation from multiple scientific angles. This interdisciplinary validation creates a uniquely robust body of evidence that conclusively demonstrates the authentic capabilities and potential of artificial intelligence through the most reliable mechanism humanity has developed for establishing truth: rigorous scientific investigation published in peer-reviewed journals. Number 8. Ongoing open-source collaboration. The transformative power of artificial intelligence stands uniquely validated by its unprecedented level of global, transparent collaboration. Unlike technologies developed behind corporate walls, many of AI's most significant breakthroughs emerge from open-source projects where thousands of researchers publicly share code, methodologies, and models for anyone to inspect, improve, or challenge. This radical transparency means that exaggerated claims rapidly collapse under collective scrutiny, while genuine advances are quickly verified and enhanced by a worldwide community of experts. When a new machine learning approach demonstrates superior results, competitive researchers immediately test it against diverse problems, ensuring that only authentic innovations survive this gauntlet of global validation. Children in remote villages once had no access to educational resources that wealthier communities took for granted. Today, open-source AI initiatives have created free adaptive learning systems deployed on basic smartphones to provide personalized education in regions where qualified teachers remain scarce. The volunteers building these systems work transparently, publishing every algorithm and dataset for public examination, while incorporating feedback from educators worldwide. These aren't profit-driven ventures, but collaborative humanitarian efforts, demonstrating how open-source AI directly transforms lives in communities previously left behind by technological progress. The medical applications of open source AI reveal particularly compelling evidence of its authentic impact. During the pandemic, researchers worldwide collaborated to develop open source algorithms for analyzing lung CT scans, with each improvement freely shared and collectively refined. This global effort produced diagnostic tools deployed in resource-limited hospitals, lacking specialized radiologists, saving countless lives through early detection capabilities that would have taken years to develop through traditional closed approaches. The open nature of these projects meant continuous improvement through global feedback, with clinicians from diverse healthcare systems contributing insights that shaped more robust and adaptable solutions. Even large technology companies increasingly recognize the value of open-source collaboration in AI development. Google's TensorFlow, Facebook's PyTorch, and Microsoft's contribution to Hugging Face demonstrate how corporate entities now advance their interests by participating in transparent collective efforts rather than maintaining proprietary control. This shift represents tacit acknowledgement that AI progresses most effectively through collaboration rather than competitive approaches, with the most valuable innovations emerging from collective intelligence rather than isolated teams. Perhaps most compelling is how open-source AI creates a fundamental democratization of technological power. Capabilities once restricted to elite institutions now become available to independent researchers, small businesses, non-governmental organizations, and public service organizations through freely available tools and models. This accessibility enables applications addressing local needs that multinational corporations might ignore, from preserving endangered languages to creating assistive technologies for specific disabilities. The transparent, collaborative nature of these projects ensures accountability while accelerating innovation through diverse perspectives. Rather than concentrating power, open-source AI distributes it globally, enabling communities to develop solutions aligned with their unique values and requirements, instead of accepting technologies designed for different contexts and priorities. This democratization process transforms AI from a potential tool of centralized control into an instrument of empowerment, accessible to anyone with programming skills and creative vision. Number 9. Incremental nature of improvements. The consistent, measurable progression of artificial intelligence capabilities over decades defies any characterization as hype or illusion. Unlike technologies that arrive with grandiose promises and quickly plateau, AI has followed a steady trajectory of improvement, documented through standardized benchmarks that allow direct comparison of capabilities over time. Image recognition systems that achieved 70% accuracy on standard datasets in 2010 now exceed 98%, while natural language processing that struggled with basic grammar a decade ago now produces a coherent long-form content indistinguishable from human writing. These aren't marketing claims, but independently verified measurements showing continuous progression through thousands of incremental improvements rather than isolated breakthroughs. This pattern of steady advancement represents the hallmark of authentic technological progress rather than cyclical hype. Patients with rare genetic disorders once went decades without diagnosis, visiting dozens of specialists without answers, while their conditions progressively worsened. The incremental improvements in medical AI systems have transformed this experience, with diagnostic accuracy for rare conditions improving from below 20% to over 85% through continuous refinement of algorithms analyzing subtle patterns across medical images, genetic data, and patient histories. Each percentage point of improvement represents families receiving answers that previously remained elusive, transforming medical odysseys into actionable treatment plans. The children now receiving early interventions for conditions that previously went undiagnosed until irreversible damage occurred represent the human impact of these methodical improvements. The transportation sector demonstrates how incremental AI enhancements accumulate into transformative capabilities. Autonomous vehicle systems improved from struggling with basic lane following to navigating complex urban environments through thousands of iterative refinements to perception, prediction, and planning capabilities. Each enhancement built upon previous work, gradually expanding operational domains, from highways to suburban streets to complicated urban intersections. This progression didn't occur through singular breakthroughs, but through relentless improvement of component technologies that collectively transformed theoretical possibilities into practical applications. The industrial applications of AI reveal particularly compelling evidence of incremental progress, creating substantial impact. Manufacturing quality control systems that once detected only obvious defects now identify microscopic flaws invisible to human inspectors through progressive refinement of computer vision algorithms. Predictive maintenance systems evolved from basic threshold alerts to sophisticated forecasting models that anticipate equipment failures weeks in advance through continuous improvement of pattern recognition capabilities. Each enhancement directly translates to reduced waste, lower costs, and improved reliability in critical infrastructure. Perhaps most revealing is how improvements compound across different domains of AI research, creating capabilities greater than the sum of individual advancements. Vision systems that incrementally improved object recognition combined with natural language models that gradually enhanced semantic understanding to create multimodal systems that reason across different types of information. This integration of separately developed capabilities produced emergent abilities that seem sudden to casual observers, but actually represent the convergence of multiple streams of incremental progress. Like compounding interest that seems unremarkable in early periods, but produces dramatic results over time, the steady improvement of AI capabilities demonstrates how methodical advancement ultimately creates transformative impact through persistence rather than revolution. This pattern of continuous, measurable progress provides perhaps the strongest evidence that artificial intelligence represents authentic technological advancement rather than cyclical hype. Number 10. Ethical and regulatory discussions. The intensity and sophistication of ethical debates surrounding artificial intelligence underscore its authentic significance beyond mere technological novelty. When world-renowned philosophers, legal scholars, and policy experts dedicate their careers to addressing AI's societal implications, they validate its transformative potential through their serious intellectual engagement. These discussions extend far beyond superficial concerns into profound questions about autonomy, responsibility, human dignity, and the proper boundaries of technological capability. The fact that organizations from the Vatican to the United Nations have established dedicated commissions to address AI ethics reflects recognition that these systems raise legitimate philosophical questions, deserving of our most careful consideration. Such extensive ethical examination simply wouldn't occur around a technology lacking genuine societal impact. Children with disabilities once struggled with educational materials designed without considering their needs, often falling behind despite having the same intellectual potential as their peers. Today's discussions about algorithmic fairness have directly led to adaptive learning systems that dynamically adjust to different cognitive and physical capabilities, ensuring that technology expands rather than limits educational access. The students now thriving academically because AI-driven systems accommodate their unique learning requirements represent the human impact of ethical considerations, translated into practical design improvements. Their success stories demonstrate how principled discussions about inclusion produce technologies that genuinely enhance human potential, rather than reinforcing existing limitations. The regulatory frameworks emerging around AI in healthcare, finance, transportation, and other critical sectors reflect careful balancing of innovation and protection, rather than knee-jerk restriction. Policymakers worldwide increasingly adopt nuanced approaches that distinguish between different applications and risk levels, creating governance structures that guide development toward beneficial outcomes while mitigating potential harms. This measured regulatory response contrasts sharply with historical patterns around overhyped technologies, which typically face either complete regulatory dismissal or blunt prohibition. The thoughtful sector-specific frameworks now emerging around AI indicate recognition of genuine capabilities requiring sophisticated governance, rather than empty promises warranting dismissal. Perhaps most revealing is how ethical discussions have directly shaped the evolution of AI systems themselves, with concerns about transparency, bias, and explainability driving technical innovations that address these challenges. Research into interpretable machine learning, fairness-aware algorithms, and robustness against manipulation has produced systems with enhanced accountability and reduced potential for unintended consequences. This integration of ethical considerations into technical development represents a remarkable departure from historical technology trajectories, with normative questions shaping design choices at fundamental levels, rather than being addressed as afterthoughts. The international nature of AI ethics and governance discussions further validates the technology's authentic significance. Countries with profoundly different cultural, political, and economic systems nevertheless engage in substantive dialogue about appropriate AI development pathways, seeking frameworks that respect diverse values while enabling beneficial innovation. From Japan's concept of Society 5.0 to the European Union's human-centric approach to China's focus on strategic development, these varied perspectives contribute to a global conversation about how to harness genuine technological capabilities for human benefit. The global effort to develop ethical guidelines and regulations shows that artificial intelligence is not just a speculative concept, but a present reality. Thanks for watching. Make sure to watch this next video about artificial intelligence.